Hello, everyone, and thank you for coming. Today, I would like to talk about a project which is called NGS. In a nutshell, NGS aims to be a general-purpose scripting framework for NGINX, and the name is a mixture of words NGINX and JavaScript. So, NGS combines two NGINX modules and a JavaScript interpreter written from scratch. And just a couple of words about me and my background. My name is Dmitry. I work for NGINX company since 2015. And that time, I participated in developing new features and new modules for NGINX open source and NGINX Plus. And since 2017, I focus mostly on the project which I'm going to talk about in this presentation. Before NGINX, I used to work with media streaming software. I work with such protocols like RTMP, RTSP, and HLS, and stuff like this. And I think that's enough about me. So I would like to start with the outline of my presentation. In the first part of my presentation, I'm going to talk about the history of scripting in NGINX. And the vision for scripting in NGINX. The next chapter is going to be about project goals, what we're aiming for NGS. So what we are trying to solve and what we are not trying to solve and stuff like this. The next chapter, I'm going to talk about the way NGS solves these problems and the way it implemented. So in the next chapter, I'm going to talk about, I'm going to show you some examples, how you can use NGS inside NGINX. So, and finally, I'm going to talk about a bit the future of the project, and so what is available. Okay, great. I'm done with the outline, and I would like to start with the history of scripting in NGINX. So to begin with, the idea of native scripting inside NGINX seems obviously useful. The problem is that sometimes the properties of the ideal scripting our team envisions for NGINX, they go against each other. So, let's take a look at these properties and these desirable properties that our team envisions. So the first point and the foremost point is that it should be fast. Otherwise, what's the point of using it inside NGINX? Because people love and use NGINX exactly for its speed and lightweight nature. Otherwise, you can use, for example, Node.js. The second point is that ideal scripting should integrate well with the asynchronous nature of NGINX. So the NGINX is in charge of the main event loop of the process, not the other way around. And the next point is about modularity. So you have to be able to disable it. So you have to be able to disable it to squeeze out performance. And finally, it should be a popular scripting language just to help people to write their scripts faster, just not to learn new language because people have other things to do than learn new languages every day. So the first try to implement the native scripting in NGINX was in 2005 when Igor wrote the Perl module. So that module allows you to write some complex logic using Perl. So let's take a look at how well that Perl module aligns with the properties of the ideal scripting our team envisions. So the first big plus for Perl module is that you can use existing libraries inside and using Perl. So that's a big plus for that Perl scripting. The second point is that you can inject or embed short snippets of the Perl code directly into the NGINX configuration files. That is quite handy, obviously. So let's talk about the shortcomings. The major issue of the Perl interpreter is that there is no support of the non-blocking operations. So that's due to the fact that the Perl interpreter is unaware of the fact that it is executed inside NGINX worker, so it can do blocking operations. So therefore, obviously it's unacceptable for the NGINX itself. So it's a big issue of that Perl scripting module. The next point is about the Perl interpreter itself, in Perl scripts itself. So typically, Perl scripts, they are expected to be executed inside their own processes. So sometimes something goes wrong. For them, it's quite natural sometimes just to exit the process. So it's not acceptable for NGINX itself, because in that Perl scripting implementation, you have a global Perl interpreter for a single worker. So that can happen, and that is obviously not acceptable. So I'm done with the history part, with the vision part, and now I would like to proceed to the second part of. So what we're aiming for. So what problem we're trying to solve with the JavaScript module. So the ultimate goal of the NGS is to reduce the necessity of NGINX users of writing new modules using C language, because as just 10 minutes ago, Vasily said that it's really a hard thing to do for most people, and even for experienced developers. Sometimes it's not the best trade-off between time and results. So again, let's take a look at these goals in more detail. So the first point is that it should be fast and lightweight. So just not to make NGINX itself too slow, and it should not have too much CPU and memory overhead, just to be able to process a lot of incoming requests in a single worker, as NGINX does itself. The second point is about security and robustness. So it means the idea is that each request should be executed inside its own isolated context from other requests. So there are two reasons, at least, to do that thing. The first reason is about security. So your code is isolated from the code of which is written, for example, for other location. It's quite possible that it's different developers, and for example, it's quite possible that in the future you can just insert the code developed for something else. The second point is about robustness. So if you have an isolated context, so you can handle, for example, exceptional situations like memory insufficiency for a given connection, and you can handle it without problems, without affecting other connections. So, and the last point I would like to mention here is, again, popular scripting language, because people don't want to spend their evenings learning. Sometimes they won't, obviously, but not at the moment when you want to solve some specific problem, right? And here I would like to give you some reasons why we decided why we chose JavaScript, right? So the first big plus for JavaScript is that JavaScript is a modern lingua franca, so you can most probably, if you don't write in JavaScript, most probably you have seen it. And that is a first big plus for JavaScript. The second point is that JavaScript has C-like syntax, which is quite familiar syntax for many developers and for DevOps. And the additional property, additional big plus for JavaScript here is that JavaScript has curly braces to mark blocks. So it aligns well with the way the NGINX configurations are written. So it is, at least in the future, we are planning to inject the JavaScript code directly into the NGINX configuration files. So it is going to be a useful property. So, and the last point I would like to mention is that the JavaScript was written for browsers. So the event-driven paradigm is natural for JavaScript. It is built into JavaScript. So and that property aligns well with the NGINX runtime, because NGINX itself is also about event loops and about callbacks and stuff like this. But in NGINX itself, you have only C callbacks, C-level callbacks. But with JavaScript, we're going to introduce, for example, JavaScript callbacks. And here, I would like to give you some reasons why we decided to write our own interpreter. So the first reason is that the existing JavaScript engines, advanced JavaScript engines like V8 and SpiderMonkey, they are too heavy to be used inside NGINX. And the reason for that is quite obvious. They are designed for different tasks. They are designed to be executed inside browsers. They have all sorts of Java JIT engines, garbage collector engines, and so all the stuff a modern browser needs, and that is quite a lot of stuff. But in the server-side configuration on the NGINX, the situation is quite different. You don't need a lot of that additional stuff. The second alternative that we looked into was a ducktape. Ducktape is a project, is the most advanced project, is the most advanced JavaScript interpreter written to be embeddable inside C and C++ languages. It's quite mature. It has a lot of features. But the problem with the ducktape is that it has a different set of priorities. So, for example, it values memory footprint, ECMAScript specs conformance, and all that stuff more than performance. And that is not a good thing for NGINX itself, because for NGINX, we want speed. And finally, when you have your own interpreter, you can tailor it to your execution environment. So that is a really useful thing, because when you have your own interpreter, you can customize it. For example, to illustrate my point, what customization can do, here I'm showing you the graph where you can see the number of empty contexts that each interpreter can create in 1 second. As you can see, the scale is logarithmic, and the NGS is at least 2 orders of magnitude faster. The reason for that is quite simple. There is no magic. Simply, NGS is designed, is optimized for context creation time. So, whereas, for example, the V8 and SpiderMonkey, for them, it's quite acceptable to introduce some delay to process the JavaScript code, to process, for example, to run the JIT compiler on that code. But in the NGS, on the server side, the situation is quite different. You can easily have 10,000 or even 100,000 requests per second for a given worker. But at the same time, for a given location, you have the same code. So you can precompile the code. You can strip any functionality you don't need. And you can optimize for context creation time. So that is why we see such figures. So I'm going to proceed to the next part, and here I'm going to show you how NGS achieves the objectives described previously. So at NGINX start time, the NGS code is compiled into a bytecode, and that bytecode is somewhat similar to CPython bytecode. That bytecode and global objects, they are stored inside the parent NGS instance. Later, in a worker for each new request, we create a copy and write in NGS instance from that parent request. So that step significantly reduces the time needed to start new NGS instance, because what you have to do is to allocate some initial memory and to make several links, and that's it. In addition, I would like to mention what copy and write means, right? It means that once a child NGINX instance changes the global object, that change is only visible to that specific request. So it means that we share a huge chunk of the code that is immutable, just to reduce the CPU and memory overheads. And the last point I would like to mention here is that there is no JIT compilation. The reason for that, there are at least two reasons for that. And the first reason is that it's about portability. If you don't have JIT compilation, if you can compile the code, then you can run it. Whereas for JIT compilation, that is not the case. And the second reason is that when you the second reason for not having JIT compilation is that the JIT compilation doesn't give you too much performance benefits, at least in the NGINX environment, because most of the time you don't have a lot of computation inside the NGINX itself. Rather, you are limited not by NGINX itself, but by NGINX itself. You are limited by the, usually you do some external API calls to the NGINX itself, and you are limited by that, not by NGINX. So here's the second part of why NGINX is fast. The next point is about the way the virtual machine is implemented. So it's a register-based virtual machine. And in comparison to the stack-based virtual machine, register-based virtual machine, they have a smaller memory footprint. For example, for small examples of NGINX, you have around several kilobytes of memory per request. The second point I would like to mention here is that according to ECMAScript specifications, the engines are expected to work with strings using UTF-16 encoding. But obviously, that is not a good idea for if you want to squeeze out the performance, because you have to allocate at least 2 times more bytes for any data chunk. So instead, NGINX uses UTF-8 strings, and that allows us to significantly reduce the memory and CPU overhead for operations with strings. The last point I would like to mention here is about the garbage collection. As most of you know, the modern languages, high-level languages like Java or JavaScript, they employ some form of garbage collection algorithms or special process that have to collect the data no longer used. But that process itself, the process of reference counting and the process of garbage collector stops, they introduce measurable overhead and measurable delays. Instead, NGINX uses a different strategy, which is more suitable for NGINX itself. It's the way the most NGINX modules are written. So instead, NGINX allocates memory from a memory pool, which is linked to the current request. And so once that request finishes, the NGINX interpreter and that cloned virtual machine is destroyed as a whole. And so it's quite cheap operation to destroy that small NGINX instance. Obviously, it works well, exceptionally well for short-lived requests. Obviously, it can introduce excessive memory consumption for long-lived requests. Therefore, in the future, we're planning to introduce optional garbage collection engine just to cope with such tasks. And lastly, in that chapter, I would like to reiterate once more what we are trying to do and what we are not trying to do. So the first point is that NGINX and NGINX is not an application server. So we're not going to replace Node.js, for example. Node.js is just fine. That's absolutely fine. What we wanted to do is to add additional scripting capabilities inside NGINX itself. So we would want to extend the NGINX configurations to make them more flexible, not to replace Node.js, for example. The second point is about strict ECMAScript specs conformance. So it's about the way the modern and advanced agents are written, so they conform to the specific ECMAScript specification. We're working on it, but it has less priority for us now because it's a huge work to do. And some quirks of that specification, they not allow us to make some additional optimization, for example. That is why. So finally, we're ready to see NGINX in action. Before we start, we have to install it. You have two options here. You can install a pre-built packet. For example, here is the way you can install that packet from our official NGINX repository. So the first thing you do is to simply add the our official NGINX repository to your sources list. And the second step is simply using apt-get to install the packet nginx module ngis. Alternatively, if you don't want to install anything, just want to simply see NGINX in action, here's the link where you can find all the examples I'm going to talk about in that presentation, and the way you can run them directly inside a Docker container, so you can see NGINX in action without installing anything if you want. So finally, we're ready to see NGINX in action. Here's the first and the simplest example. The first thing to do you have to do is to load the module. You do this using the load module directive. The second directive we have to configure is named JS include. So it takes as its argument the relative path to the file where you are going to write your NGINX code. And the last directive we have to configure is named JS content. That directive takes as its input the name of the JavaScript function, which have to be defined in the file. So as you can see, we're writing the standard JavaScript function named hello. That function takes as its argument the request object, so it's a slim and small wrapper around the NGINX HTTP request structure. And the last thing we have to do here is to use the internal method, which is called return. It's quite similar to the return directive on the NGINX itself. It takes two arguments. It takes the return code and the body of the HTTP reply you're going to say to your client. So that's it. That is all you have to configure. Now you can check, for example, it with the curl program. Here's the second example I'm going to show you. So it aims to illustrate the NGINX capability for our streaming, for our TCP and UDP proxy. So as in the previous example, first of all, you have to load the module. And this time, though, you have to load the stream.js module. The second step is similar to the previous example. We're simply configuring JS include directive. And the last step you have to configure here is the JS filter directive. So as JS content directive, that directive takes the name of the JavaScript function, which have to be defined inside your NGINX file. So please take a look at the function we named header inject. So here we're using a special method called on. It allows us to register a JavaScript callback, which will be called each time a new data from a client arrives. Inside that callback, we are looking for new byte character after a request line. So the the main idea of that example, so what we're trying to solve, imagine that you, in your streaming proxy, you have to add HTTP header into the HTTP request that passes through TCP and UDP proxy in NGINX. So in that example, we simply register in our JavaScript callback. That callback looks for the new line after new line character after request line. Once it found it, it simply inserts our my variable, which has the foo header, which we are going to inject into the HTTP request. And finally, it simply detach that JavaScript callback from the upload event. So it is simply to reduce the CPU overhead, because no more processing is required. We don't want any JavaScript invocations anymore, so we just detaching it once we've done it. Okay, and here's the third and the last example I'm going to show you. It's aimed to illustrate the capability of the subrequest method of the HTTP module. So in that example, we're going to make several asynchronous subrequests to at least 2 in that example backends, and we're going to collect them and return the joined, a combined result to a client asynchronously. So the first thing we're doing here is that we are using the auxiliary function named join subrequests. So that function takes the request object and the list of the subrequests, a list of the subrequest locations to which we are going to make subrequests. The join subrequest function does the following. So it makes in parallel several subrequests invocation, and the subrequest function allows you to make native NGINX subrequests to any NGINX location, and once it finishes, the done callback will be called. So the second argument is done is a callback. So and here is it, our function done. So as its argument, it function takes the reply object of our from the backend. So first thing it does, it simply stores the data response body URI into a JavaScript array. And last thing it does, it simply checks the number of elements in that parts array and the number of the subrequests. And once they are equal, it simply returns to a client the joined and combined combined result. And you can also see that we are using here a JSON stringify function, which is a native function of the JavaScript interpreter. So which allows you to stringify arbitrary JavaScript objects. The last point here is about the way you can debug your scripts. Because without it, it's not that easy to debug NGS, because without it, you have to, for example, tweak the code a bit, reload NGINX, and to look into the NGINX logs, which is not that easy. Instead, you can simply use that command line interface, which is also distributed with the modules, or you can run it directly from our official Docker container. To illustrate what it can do, I'm going to show you some short snippets of user interaction with it. So the first thing is about the pretty print of random JavaScript object. The second point is the way you can, for example, calculate hashes in the same way as you can do it inside Node.js, for example. The last point is just I'm showing the way you can see the debugging capability, so that something goes wrong. Yeah, that's it about the examples. And here's the last chapter I'm going to talk about. So what is currently available? What is already present? So the first thing I would like to mention is that the native JavaScript objects, in according to ECMAScript 5.1 specifications like object, array, numbers, strings, etc., they are available. The second point is about exceptions. So you can, through them, you can catch them in the usual way. The second point is about closures and anonymous functions, which are also available, as you can guess from the subrequest example. The second point is about at that moment we have two embedded modules, which are called crypto and FS modules. So they allow you to, for example, calculate hashes or work with other cryptographic primitives. The second is about file system. So you can, for example, open files if you want, or write to a file, for example. The next point is about what is not available. So, for example, eval function is not available. We're not going to implement it anytime soon because for performance and security reasons. The next point is about the ECMAScript 6.0 and later additions. For example, the way you define variables using let and const, which are about later additions from 6.0. And for example, arrow functions, they are unavailable right now, but in the future, we're going to add the most useful features from the next and later specific specs of ECMAScript. The last point is about modules. As I said, at that moment, there are only built-in modules, and there is no way for you right now to, for example, load the random module from a file, for example. Probably this is the most, from my perspective, unknown issue right now. So right now you have to collect all your code in a single file. But we're going to solve it, and I think it's will be a part of history. Okay, and here's the last page of my presentation. Here I would like to give you some what we are aiming for, what our general strategic plans with NGS. Okay, the first big direction is about. So it's about integration with the NGINX itself. For example, embedding NGS into NGINX configuration files directly. It will be, I think it's a good thing to do because it, for simple use cases, for example, for variable handlers, it's quite handy. The second point is about extending of the feature set of the modules. The second global directive or the direction is about the NGS engine itself. The first point to mention here is the extension of the ECMAScript's conformance. And the second point and the last point here is the module support. This brings me to the end of my presentation. You can find everything you want on our official GitHub. So there you can find you can ask any question. You can also ask questions, any questions to me, whether in person or through email, which is available. And also you can create issues, you can ask questions on our official GitHub page. That's it. Questions? Yeah. Depends on the configuration. So it's so you're talking about the inserting headers, right? Okay. NGS itself, it doesn't have special tricks. It uses standard NGINX API calls. So it uses standard structure to insert headers. So there's some quirks. For example, you can you can't replace several special types of headers, like content length, for example, because they are handled separately. But about priority, there is no how to say it. I think I'm going to answer you later that question. Okay. Okay. Yes, it's possible. You can load directly into the NGINX logs with several levels. Oh, I see.
When you test the NGINX configuration, do you already find out if you're, for example, missing the function that you want to?
No, because it's quite probable in the future you can, for example, during the configuration phase, that function will be created in that environment. Not from the source code, or dynamically, for example. So at that moment there is no check for that.
So in general, it will be more like you find out problems during runtime.
Maybe where we have to look into that problem specifically, if it's a really painful one. I don't know. Okay. Nobody catch it. Your connection, you are getting the 500 error, so it's handled. So the processing stops as usual. Okay.
When you combine the response from the subrequest, what does the main request send to the client? Does it use the header from the first subrequest, or does it compose it?
Yes, it's the same. So it uses the native NGINX API. So it uses headers from client request. But if you want to change them, you can change any header inside that specific location. So that's the way you change any headers. You can, for example, configure the I don't know, TLS or any additional properties specifically in that location, not in the NGS. Okay. Other questions? Okay.
Are there any tools for debugging running modules, or when your module might crash?
Yeah, that's for running programs. There is no tool right now. But as you do in any other situation, you can, for example, log anything you want into the NGINX log file, and to see what is going on. In addition, you can use a command line interface to debug the NGS code itself.
Can the script be written for a different phases?
I see.
Can the script be written in a different phases, content phase and access phase?
Oh, that's a good question. Actually, for example, in the stream module, there are several phases where you can inject your code. For example, the stream module, you have pre-read phase and access phase. In HTTP header or HTTP module, you have only at that moment content phase, but we're considering adding additional phase handlers and additional entry points for NGS itself.
So what phase does it currently support?
I'm sorry?
What phases does it currently support?
As I said, in HTTP module, we have only content phase, I think it's, and you also can execute arbitrary code inside inside variable handlers. So, for example, you can create new variables using NGS, and you can run arbitrary code at the moment of the evaluation of that variable. Okay.
That ties in with my question. I wonder, to what extent is it possible to interact with NGINX variables?
Yeah, it's possible. For example, you can create them using a special directive, which I didn't mention, which is called JSSet. And you can create new variables using JavaScript. And in addition to that, it's quite easy. You just use for existing NGINX variables. You can simply look at into any of them using the r.variables.arbitrary name of your variable. So it's quite, I think, useful. Any questions?
Yes.
Okay.
The graph you showed,
Yeah.
the factor 100 speed increase.
Yeah.
Am I right in thinking that for every request, an environment is created and then tear down at the end of the request?
Yes, a new isolated environment is created, so they are quite separate. So the global environment every time for every single request is new and different from other requests. But again, I explained a bit how we do it in a fast manner. So how we optimize it. For example, we use the parent NGS instance, which has the global objects, and all the child NGS instances, they share that some code and some objects in that global NGS instance. And when they change these global objects, that change is only visible for that specific child instance. So there's no mixing of NGS instances. Probably, in the future, we are going to add additional way to interact, for example, to store, or for example, in a shared memory, something that is, so for example, to implement some kind of counters, because currently the NGS instances, they created each time a new request arrives, so and destroy it after it finishes. So at that moment, you have to, for example, use only subrequests and you have to go, for example, to Redis or whatever you want to implement some kind of counting, if you want to. Oh, okay. I think I'm running out of time, and thank you, all of you.